This is first presentation, the accidental load of žeželj bridge analysis of solid caisson bridge interaction. This paper showed the influence of exceeding load of foundation caisson žeželj bridge in Novi Sad. The exceeded load occurred beginning in 16 of the 20th century.
Share the screen with us.
We don't see your presentation, we just see your face.
Excuse me.
Thank you.
Excuse me. Is it? Wait. Where is?
You can share your screen also.
Wait. Znači, ja tebe vidim, samo da vidim. Share screen and
that green icon down on your computer's desktop.
Share screen.
Share screen and just choose the screen which you will share presentation.
Yes.
Yes.
I know. Excuse me. That is right. That's right. Is okay?
Yes. Thank you.
This paper showed the influence of exceeding load on foundational caisson žeželj bridge in Novi Sad. The exceeded load occurred at the beginning of 16th of the 20th century. That is only a few years after the facility was put into operation. Long-span arch, RC bridge or PC bridge is not designed in the plane unless there is solid rock and the shoulder supported. Of course, žeželj know about the foundation problem in the banks of the Danube in the vicinity on the Novi Sad, where the soil usually loose, clay, alluvial sand, and gravel, so the envisioned immovable support or caisson on the bank on the center of the river. It is known the list of the older generation. The žeželj first performed its so-called pre-stressing of the soil, namely behind the caisson toward the coastal part, and soil replaces that thanks to the RC diaphragms that were located between the caisson and the soil. Passive resistance was activated with the help of hydraulic presses. Therefore, with the processing of the soil consolidation correction was executed, all horizontal moment of support caisson, the wall naturally occurred those endanger the building were carried out during construction before commissioning. This means the sum of horizontal moment included the creep of concrete. This made the bridge stable with immovable support, or so it was true. A few years after beginning commission, žeželj bridge was subjected to flood wave, and considering the banks were not adequately supported, the integrated bridge was threatened. During the flood, there was an urgent intervention with ballast, probably riprap or rock, in order to protect the bank from erosion and ensure the immovable support. In this paper, the interaction of the structure and the caisson with the ground was analyzed through possible stage of loading. Different levels of influence and possibly adequate combination were treated. Passive resistance of the soil and sliding in the coupling well on thrust force in the caisson. It is the base. The project of rad impacts, the modern project of the rad impact story is not treated here, but exclusively the calculate method were current late 1950 and early 1960s. Let's not forget the whole project of the format conceptual level was done by Branko Žeželj in one sheet, so 2-page of A3 format, where all the necessary dimensions of the bridge were drawn with a single formula for the moment of a simple beam. After that, the entire team of engineers worked the several months of the contractor project in order to state that there were no significant difference in dimension between žeželj's conceptual project and the contractor project. This is a cross-section, right, and view of the bridge left. It is a long arch and small arch. It is right banks. it is erosion left bank and caisson and danger of bridge integrated. This is longitudinal sectional plane of the bridge, but we have looking the caisson left, right, and in middle in the river, central caisson. Cross section of the caisson, right bank of Danube. Right bank caisson bay, deeper foundation in 64 meter of water. First layer of soil, the thin surface layer of muddy sand, and second layer fine compacted gravel. Width of this caisson 24 meter, and long is 60 meter. It is left caisson, cross section of the caisson left bank of the Danube. Left bank caisson is E. First layer of soil is 10 to 12 meters, sandy clay. Second layer is 20 to 50 meters, fine gravel, grained gravel. And third layer, blue hydraulic compacted clay. This is a central period caisson. It is eccentrically because it is different of lateral forces on big arch and little arch. This is picture žeželj bridge without coastline with coastline after building. It is without riprap on coastal is not adequate. This is a plain view of banks, a new žeželj bridge, this, and the Varadin Rainbow Bridge. This is right caisson on old original žeželj bridge. This is embankment around the caisson of the right bank during 1965 flood. This is a riprap, and this is arch little. Lateral force in soil resistance is left caisson, the similar the right one. This is AB diaphragm, and this is a caisson, and this is finished after position the planning level of caisson, and after pressure activate passive earth pressure of the soil at its horizontal forces is 13 height of AB diaphragm. But another forces is base shear, but not base shear is for earthquake. It is base shear for passive earth pressure. It is approximately calculated the incident load. The passive earth pressure is left for dry unit weight is 20 kilonewton per cubic meter. Internal angular friction of about 4 degrees. Height is 11 meters, and height of AB diaphragm is 8 meter, probably, and its resonant horizontal earth pressure who is activated with a reinforced concrete diaphragm. And it is right, is saturated soil conditioner. Sorry. It is submerged unit weight is 10 kilonewton per meter cubic. Angle internal is not different, but maybe decrease. But depth is decrease for 1.5 meter to 11 to 9.50 meters, and activate passive earth is only 60 and 6 meganewton. And base shear is adequate to calculate normal forces on the base in the caisson and activate for angle of friction base shear for great wall, great arc is 70 or 43,000 kilonewton, but you assume is adequate to activate reaction for big arch and case horizontal arch. For small arch, is base shear is 11, 12, 9, 10. Oh, but is without self weight of caisson. Sorry. It is below the deck view is repair middle caisson after moving right caisson after flood erosion. This is repair of small arch, and this caisson, a pair of arch, is movable about 10 centimeter in 1965 after flood. In the previous approximate calculation, the dimensions of the RC diaphragmatic caisson and the soil condition satisfy and do not satisfy the requirement of caisson stability are presented. Change in influence in the arch for moving support can be calculated tabulary. This maybe. Lack of sufficient repair upon the bank and extremely large flood in 1965 threatened the integrity of this unique bridge due to extreme load was exposed at the time, causing erosion and caisson to move. Bridge had to repaired in the following decides. Also, the maintenance of bridge was not at the appropriate level, but the genius of designer and the skill of contractor, and as the robustness of the building saved this bridge. Unfortunately, as if all that was not enough, the destructive drive of NATO destroyed this unique bridge in 1999. Professor PhD Žeželj Milenko. This is acknowledged for Ministry of Science, Technology, Development and Innovation of Republic of Serbia, contact on 2024. And this is a reference, and I close this